Just for those who don't know who I am, my name is Mack Hendricks. I am one of the co-founders of Detroit Black Tech and one of the architects of Hacking with the Homies. This session is called Contain Yourself with Docker and Serverless. And we have Shelton joining us. You want to give your intro, Shelton?
Hey everyone, I'm Shelton Graves, currently the PMM for Azure Functions. I've been in the tech space for about 7 years now. I've held multiple positions, computer science background. I've done IT help desk, sysadmin, and now I'm doing product marketing for Microsoft.
Great. So, man, I'm so happy that we're able to get you to come hang out with us today, man. For those who don't know what a PMM is, they may not know what the acronym is. What is that?
Yes, thank you. So PMM is Product Marketing Manager. So I sit between our product team, our sales team, and then oversee the core marketing for my product that I support. So us talking about Azure Functions today.
Great. Okay. So let's jump right into it. So, what is it? So we're talking about two different things, right? We're talking about containers and we're talking about serverless. So, containers is something that's been around for a while, right? But it's usually used to run a single software process, right? Example is a microservice. It's kind of a form of operating system virtualization. It's kind of grew up in that space, right? So, and I have a diagram and chart that talks about it in a little bit here, so you can see it. But it's probably the most popular implementation of this is Docker. There's a number of container implementations, but probably Docker is probably the most popular version of a container. So from a serverless standpoint, it's really, you don't have all the baggage that goes along with a container, right? Because you need to know how to build it. You need to know how to kind of run it. So there's a lot of responsibility on your part or your operations teams to manage it. But with serverless, you're really responsible for executing like a piece of code by dynamically allocating resources that typically you don't have to manage. It's usually the cloud provider that's managing that for you. And execution is usually in the form of a function. So if you go back to your programming basics, is pretty much you can, inside of a function, you have the core raw application logic. You're just responsible for that. And then obviously, as I said before, it abstracts you away from the underlying infrastructure. So let's go on and talk about like, why should you care about this? Containers. It's been around for a long period of time. It's foundational technology. You should know about it because a lot of the modern cloud technology today leverages containers. So that means like your Kubernetes, you need to understand containers in order for you to leverage Kubernetes. There's other orchestrators as well, Docker, and then just some organizations have just decided to leverage containers for making it easier to deploy certain applications, maybe to their development teams, which is what I'm going to talk about a little later. From a serverless standpoint, why should you care? And this is where Shelton may come in and say, Mac, you may be wrong, but and give his input as well. Is that it's really great for short-lived stateless application logic, not really for long-running processes. It really allows the developer to focus on their core logic, so they don't have to worry about how to build something and then how to actually execute it in runtime. First, let me just stop and say, Sheldon, anything I missed there from a serverless standpoint?
Yeah, so one of the additional benefits is it's pay per use. So instead of having, let's say I'm trying to run an API and I have a web server and that web server is continuously running and polling versus with serverless, you're only charged for when your API is being called. So you're not being charged to pay for running continuously 24/7. You're only charged once the execution. So it's one of the benefits of serverless is being execution based model.
No, great. No, that's a good point. Yeah, because that's the other thing. Like I didn't really take into account is like the monetary aspect of it, right? So, and I think as you move up, as if you're a developer looking to move up in your organization, I think people in your organization, like leaders in your organization, really appreciate when you look at the dollars and cents and start having those conversations with them and saying, you know what, we can potentially architect this using serverless, which will decrease the amount of money that we have to spend on the actual underlying infrastructure in order for this application to run. So that's a very good point. Moving on the trade-offs, if you really look at it, containers give you a little bit more control, obviously, because you can actually control what is actually put inside the container. You got control of where it runs. But then really the downfall here is that you need to understand it all, right? You kind of have to understand how to build a container and how to run it effectively. And basically, the other thing is like, what do you do with reliability and HA, right? So how do you deal with situations where a container dies and you need another one that actually pop up? Those are all, you need to now start understanding how orchestrators work. Or again, there's different ways you can deal with that. From a serverless standpoint, I believe, and this is where I want to ask Shelton as well, is he has any other additional stuff, but I think it's like, from what I've read around this is that it's a little bit harder to debug performance issues because you really don't have control of the runtime environment. And then from a portability standpoint, you're really kind of locked into a particular implementation of a cloud provider. So I don't know, Shelton, any things there, anything you want to point out that I may have missed?
Yeah, another thing is in the serverless world, there's this notion called cold start. So cold start is, so going back to our server example, so we have the server, it's ready to answer any calls when we send a request to it. When we move this to serverless, things change a little bit because with serverless, when I have a HTTP call that I'm sending to wherever my functions hosted, wherever cloud provider, at that point where that request is being made, the cloud provider needs to allocate compute to answer that request. So there's a bit of a lag time between, and then we're talking nanoseconds, is being made and for a compute resource to spin up to serve that function. So it's called cold start. So that's one of the trade-offs with using serverless as well. There's this short bit of lag. Typically, there's ways to get around it. You can pay more. A lot of these cloud providers offer more premium offering to have a pool of pre-warmed instances. So as the moment that's being called, there's zero cold start time. Or one of the tricks that's used is you just 10 minutes, every 5 minutes it's warm. So you don't have to deal with the cold start time. So that's one of the trade-offs with using serverless as well.
Oh, good. No, that's a good point. I like that. I didn't really realize that. So that's a really good point. So I think we covered why should you care. Let's just talk about the architectures a little bit. So this is kind of a little bit of a history lesson. So if you look at the left here, virtual machines has been around for 20 plus years. Even back in the mainframe days, they had some concept of virtualization. LPARs back in the day, for those old folks out there, I think it was called. But yeah, physical server. You had a hypervisor, really a lightweight OS, and then you're able to have virtual machines running on top of that. And that's and that's kind of something that people are used to. That is a very common architecture. VMware is pretty ubiquitous throughout the IT infrastructure. So as progression happened in the IT industry, people saw value in being able to move that model to not just having a virtualized OS, but actually taking an application and actually virtualizing that. So now with Docker and other container architectures, it really consists of the physical server, the host operating system, and then in this case, I'm looking at Docker. You have the Docker engine that provides a layer, and then from a layer of services. And then from there, you have these Docker containers that resides on top of it. And it's really, you're really just packaging up the app itself to be running. So you can have multiple of these containers running on a physical machine, right? And then you move over to serverless, and now with serverless, it's kind of changed the game, right? So now you don't need any of these layers of architecture. At least you don't need to run it yourself. They're still there, but they're being run in the cloud, right? And really, you just have your code, and you're uploading your code into one of the cloud providers, and there's open source serverless architectures as well, so you could run it on premise. But most people are running it in one of the cloud providers, and you don't have to worry about all of the underlying components that virtual machines or containers really make you have to worry about. So I don't know, Shelton, anything that I missed there, or any other comments you think around that?
Yeah, so like on this diagram for the service architecture, one thing serverless is in the and cloud native, for those who don't know, is taking the abilities of applications that are built in the cloud that are taking advantage of what capabilities we have now that we have cloud computing and are not limited to on-prem data centers. So one of the benefits of serverless is that you can break up things into microservices. So if you look at the diagram, there's the purchase function. So this is a high-level architecture for a e-commerce platform or website. So you can break up after that API gateway, you can break up your functions into microservices. So a specific function does one task, whether it's kind of retrieving data from the database, or it's triggering another service to say like, hey, I'm done, go move on to the next. So that's one of the key benefits of it being a cloud native pattern, is that you can take advantages of what the cloud offers and kind of breaking things up and to create a scalable architecture.
So great. No, that's great. And I think that's the one thing I kind of missed, is that with serverless architecture, let me say it another way. Like in the Docker world, it's best practice to say I want to run one particular function or task or process per Docker container. That's just best practice. Nobody controls that. Nobody says that you have to do that. Nobody's going to come over you, and your application will still run. But in the serverless world, really, you are really limited to really one task per function, I guess. So it kind of enforces that best practice that we've all in the Docker world has been trying to do. So all right, so cool. So let's jump right into like some code, and let's get it popping. So I have a repo. So for those who've been following, if you're in the sessions, if you've been in the sessions, you know that we have a central repo that have all of the actual talks in it. So on day 2, you can actually click the repository here. You can just open up in a new tab. And this is what we'll be running through. So the first thing I want to do here is just kind of clear my screen here. And I wanted to at least give you some basics. I mean, Docker's been around for a while, but I wanted to like at least start with the basics so that we're all on the level playing field. So one, you can install Docker. You can just follow this link here, and it'll allow you to install Docker for different operating systems. The other thing here is that what you will find is that once you have it installed, you're going to have a command called Docker. Run that command, it's going to give you, all the different commands that you can leverage. For what we're going to do here, I'm just going to actually just cut and paste what's in the repo. So what I'm going to do here is I'm going to run a Docker image that I created. Is this a static site? And this -p here is going to export the actual the port that I'm using for this web server. So this is just a static web server that is Dockerized in this case. So inside the Docker container is running on port 80, but I may have something already running on port 80. So I actually can use this flag here to say, whatever's running on port 80, I want it to run on my local host as 888. So let's go ahead and run that. And I already have something running on 888. So what we'll do is we'll do Docker PS and we'll do a Docker kill. And Docker kill allows you to kill off a instance that's already running, because you only can have one thing running on a port. Like I exported port 80 to 888. I only can have one thing running on port 888. So let's go ahead and do this again. All right, so what this did here, actually, let's do something even better here. So so there's a concept of images and there's a concept of containers. And there's I'm going to do this. I'm going to remove the container so you can actually see it. And Docker image. All right, so I removed this image. That way we can actually get the full effect here. So I'm going to actually run it now. So what is it doing? So basically said, unable to find image locally. So what it did, it actually went to Docker Hub, which is where all the actual Docker images are stored. It doesn't have to be, but that's kind of like the central place. You can run your own Docker Hub inside of your organization if you want to. But what it did, it actually pulled down the Docker image that I actually uploaded to Docker Hub. And what happens is that with Docker, everything is stored in layers. And I'll come back to explain what layers mean in a little bit. But now it's running. And what I'm going to do now, I actually can just open up a browser. And it just says, hello, Hacking with the Homies Developer Conference. So right now, this container was downloaded. It's running Nginx, which is a very popular web server. And it's running what we call in foreground right now, right? So you see it here, Nginx is running. I'm going to do a Control-C. And in general, I typically want these things to run in background. I don't want it to be running in the foreground. So I'm going to add a -D here, right? And this -D means run it as a daemon or daemon, whatever way you want to say it. So it runs it in background. So I'm going to rerun it. And you're going to notice here that it actually comes back what's called a unique identifier here. This is the image ID. So every time you actually run an image, it creates a container, right? Because the image is what was built. In this case, the image is this static website. When I instantiate this or run it, it creates an instance of that, and that becomes a container, okay? And each container has a container ID. So let's go look at this. So here goes the name of the image. Here goes the container ID. For readability purposes, it only prints out the first 12 characters of the image ID, okay? The command that actually is used to start this image, how long it's been running, the status, and then what ports that is actually using. So you'll notice here it's running port 80 TCP internal to the image, and then it's exposing it on port 888 on my local machine. And then you'll notice here, name. So Docker gives, if you don't give your container a name, it has a random list of names that it actually gives it, okay? So if you want to give it a name, you can give it the -- name flag. So actually, I'm going to really quickly just kill this one. I'm just going to do a Docker kill. And all right. And I'm just going to rerun this again and give it a name. Oh, I already used that name. So let's use a different name. All right, so I'm just gonna do a Docker PS again, and now I have an actual name. Now, why is this important? Well, you may have multiple like containers running, and if you have these really weird names that Docker assigns to you, it may make it hard for you to figure out what you have running. So I usually like to assign my images a name. Okay. So all right, so now we already kind of went through this a little bit around Docker PS. And really quickly, a couple of things really quickly is that Docker PS gives you, just like in the Linux operating system, you can actually see what processes are running. In the Unix operating system, PS allows you to figure out what processes are running, right? Inside of Docker, you can do a Docker PS, and that'll show you what Docker processes are running. So just to kind of help you out, understand the taxonomy a little bit of the naming conventions. So let's kind of look at the Docker file that we're using here. So the Docker file is in this directory called static site, and let's take a look at this Docker file. I'm sorry, I don't use any IDEs. I am hardcore VI guy. So I'm sorry for those who like IDEs. I don't have anything against them. I just know this. So what's happening here is that in this Docker file here, the Docker file is used to actually build your Docker image. So the from here is so there's a couple of keywords here. So the from keyword specifies the base image of our actual image. So in this case, it's Nginx. So Nginx has a image out there that's supported on Docker Hub, and I'm using that as my base. Sometimes people will use an OS as the base, like you would use like CentOS, or you'll use Debian as your base. So, and when I say from Nginx, it doesn't mean it's not running an OS. It just means that it's running an OS with Nginx already installed, right? So I'm starting from a base already. So I don't have to install Nginx. When I use this particular base image, it already comes with Nginx. And then what I'm doing, I'm just copying over a wrapper script that is responsible for starting up Nginx. I'm also copying over some HTML as well. And that HTML, I copied over into the container, and that container will into that container, and the container has the files for the Nginx server sitting at user share Nginx HTML. And then from there, I'm using another keyword called CMD. And CMD is basically stands for command, and this is the command that when the actual container starts, this is the command that is actually going to run. All right, so that's what that's doing. And I actually, in the repo, I list out these commands. I also list out some couple other commands that is important inside of Docker. So there's a run command, which allows you, when you're building the Docker container, I actually can have it do certain things. Like in this example, I'm going to have it run a make directory command to actually make a directory inside of the container. Also environment, env. This allows me to set up an environment variable so I can pass to the actual container when it's actually started. So I usually use this to pass, API tokens, any type of secrets that I need to pass to it. I would typically put it as environment variables because you don't want to hard bake. You don't want to bake those into the image itself. We have a session later on the day called Managing Your Secrets, and it'll talk more about that concept as well. So I'm just going to talk a little bit about how do you, kind of go through a use case of why and how you would build a Docker image for your organization. So the use case here is we have an application being built by a team of 5 people. The development team has selected Python, and they have a set of dependencies that should be installed in each person's development environment. Well, this is a great example of why, and for me, it's how I use Docker today, is that I don't want my development team to have to worry about all the dependencies that's needed to start doing, software development. I want them to be focused on writing application logic, not, messing with dependencies and installing stuff on their machine. So, so in order to do this, you can follow the steps here. Also, the Docker file for this is already in the repo, so you can just use that if you want. But this here is this kind of a step-by-step how you would do it. So inside of a Python application, you specify your requirements. So in this case, in order to run a web app that has some API routes, I need to install a library called Flask. So I'm going to put that into a requirements.txt file. The other one here is called, I want to figure out the base image I'm going to use. So it's, in this case, I'm going to use Python. So before I use Nginx, in this case, I'm going to use Python. And then I'm going to copy the requirements file over and other files into the container. So remember we talked about the run command here. This will actually make a directory called app. And then you're going to also run a copy command, which is going to copy whatever files that are needed into the container. And then I'm going to run the run command again, which is going to actually run and build, go and grab the requirements and build them and put them into the container. Then we're going to set up some environment variables that we can use later on. And then we're going to run a command here. And this command is just simply, it starts Python. And this is the actual app that we're actually running, is in a directory called, in this case, we're copying it to a directory called app.py. And then we're going to build it and run it. And you can push it to Docker Hub if you want. So let's kind of get to it. And then I'm going to turn it over to Shelton to actually go through some serverless stuff. So I'm going to go back. I'm going to go into a directory called base app. I already have this Docker file. So this is basically what we just went through. Okay. I'm going to show you what the requirement files look like. Pretty simple. This has one, Flask. And then we're going to just, we're going to actually build this actual file. So how do you build? So I'm going to do a Docker build and then with a -t. -t is means tag. So I can actually tag this image. And I usually, since I can push this to Docker Hub, I usually tag it with, the format is usually tagging it with your Docker Hub username / the name of the actual image itself, right? So in this case, I'm just going to name it Mack Hendricks. The name of it is base app. And then I just give it a period, for meaning that it's going to grab the Docker file from the current directory. I could give it a -f and give it actually explicitly give it a Docker file in some other directory. But in this case, I'm gonna build this here. I'm gonna explain what's happening here. So I'll let it build for a second, and then I'll go back here and kind of talk through what's happening. So so the first thing it did, it went and grabbed our base image, which is Python. If you notice here, everything is done in layers, as I talked about. So what happens is that, think about a cake. So every layer, so basically it goes in every time it executes a command, it creates a layer. So just think of it, it's just building on top of each layer, very much like a cake, or as you think about a building being built with bricks, right? So it went and grabbed, it went and created a directory called app. It copied everything that I have in my current directory into a directory called app, which is what I just created. And then I executed this command here, which went and grabbed, which caused it to actually run a command that goes out and collects all the dependencies for my application. So if you remember, I just specified one dependency, which Flask. Well, Flask actually requires a set of other libraries, right? So it went, collected Flask, collected another library, or a set of libraries that were a requirement. And it actually stuck that all inside of the container, right? And that happened in a particular layer. And then from there, it added some environment variables there that we can use. And then lastly, it actually, it actually specified the command that will run when it executes. Sorry, so now that we've built our container, we can actually run it. I'm actually going to use a different port number because I don't want to conflict with it. So I'm just going to put my name back, and I am going to use port 889 for just to make sure I don't do it. So if you notice here, when it ran, I'm running it in the foreground just so we can see this, is that it specifies that it's running on port 5000 internally, but again, we are running it on 889. So if I go over here, switch my port to 89, we should say hello hacking with the homies. So so now I could push this to Docker Hub if I want to. I already have it already there, but we'll just push it again. So, and base app. And I just need to get rid of that extra R. So, and what happens here is that it's pushing it to Docker Hub. Now, if you aren't already logged in, if you don't have an account with Docker Hub, you can go to Docker Hub and get an account. But so I was already logged in, so that's why I was able to push it to it. So if you notice here is that these layers, as I said before, some of my layers already exist. I didn't make any changes, right? So it didn't have to update much. Now, the first time I actually ran this app and pushed it to Docker Hub, it actually had to upload all of the layers, right? So that's one of the things you can think, you also need to think about as well, is when you're building this, especially in corporate environments, you want to kind of make sure the size of your Docker image doesn't become huge, right? So if I just look at this, and I look at Docker images, and I look at this image here, this Docker image isn't big at all. It's 133 meg, which isn't bad. I have some images that I'm working with that are 1.1 gigabyte images, and there's ways to actually reduce those as well. Sorry, so I'm going to stop and turn it over to Shelton, because the question becomes, why do any of this? Why not just go serverless? So let me just turn it over here and get back and give him control.
Thanks, Matt.
So, No problem.
All right, let me share my screen. All right, looks like everybody can see. So and can everyone hear me? Can you hear me, Mack?
Yes. Yes, I can.
Okay. I'm going to do, I have two demos here. I'm going to do the first one in the IDE, but the second one do in CLI. One of the common use cases, or just get into serverless, is doing a serverless API. So HTTP backend calling some type of database, so you have a web app, and you want to create an API to go call that. So I'm going to do it in the IDE just to show you how easy it is. So I'm in VS Code, and in VS Code, we actually a Azure Functions extension that you can find. Really easy to create your first function. So we'll go to the extension, X that out, and then we will create our first function. So pick a folder. So let's just create one here, call it with the homies 21. Just all right. All right, so we've created a folder. And then from here, the dropdown allows us to select our language. So JavaScript, TypeScript, C#, Python. It's a whole family of custom handler. So if there's a particular language that maybe isn't supported, so let's say if you want to write a Go function or write a Ruby function, write your code, and then we would package that code with the function and be able to run. So you can run other languages that aren't currently first through Azure Functions. So let's just do JavaScript for this demo. You can see we have a list of different triggers. These are different event triggers that we can. So the time every Monday at 5 p.m. I want to set this function up to, or you can set up a function to anytime a new entry is posted into your Cosmos SQL database, execute this function. So there's a list of different event triggers that you can use with functions. So just for simplicity, let's use HTTP trigger. We'll just leave that as a default name. Choose authorization level. Since this is a public endpoint, we'll choose anonymous, and then we'll just develop the current window. We'll just overwrite earlier. And then it generates, just in a few seconds, it's going ahead and generated and scaffolded our function in just a few clicks. So if we go to this index.js file, you can see this is our function that we created. This is the what's going to execute, and this is where you write business logic. So maybe it's not calling a database, but if it's connecting code here to connect your function. The benefits of Azure Functions is that the open source, the runtime is open source. So with Azure Functions, the same runtime that's used on the Azure Managed Service is the same runtime that you can use locally. So what advantages that brings is from a debugging standpoint, which can be troublesome when it comes to functions if you don't have a good local test environment. So with VS Code, actually, you can, with F5, start debugging your function. So you can see down here, it's starting up. and you'll see Azure Functions Core Tools, which is our runtime version. So that's spinning up, and then you can see that actually 2 functions launched since I did one earlier. But if I click and move that
Chuck,
over,
can you make your screen a little bit bigger? Can you
yeah.
make your screen? People in the chat just can't see it, I don't think.
There we go. That a little better? Oops,
Yes. Yes, thank you.
So our function is running locally. It's executed and it's currently running. So from here, we have our function running locally. To get it up to Azure, using the extension. So we'll go back to the extension and then click here, and then ask us, like, how do we want to create a new function app in Azure? So we'll go ahead and click this, write a name, so demo testing 19. We'll choose our runtime stack of how we want the function to run. So just use 14 LTS, run this on a Linux. And then consumption is the pay per model. So you get 100 free, a million free executions. Is what I was talking about earlier with the cold start. So the premium offering avoids that cold start lag. But just for the sake of this, let's do consumption. Resource group, we can host all the resources. So we'll just do that as well, which temporarily holds the code for the function. So we'll just create a new one as well, keep the same thing. And application insights allows us to monitor that function. So we'll go ahead and create an instance of that. And then we'll choose a region. Since we're broadcasting out of Detroit, I'll choose the East region. And then is now deploying Azure. So it makes it really easy to deploy us to Azure. One thing is serverless and some of the advanced how function. So I have a function here that let me zoom in a bit. I have a function here that I built before, and give me 1 second. Okay. And this is application insight. So this is how we can this application. Let me click here. All right. Wouldn't it be a demo if something didn't go wrong? All right, let's try this again. Let's try it one more time to see if it works. Okay, now it's offline. All right, so we'll move on to so one of the benefits of the open source runtime is that what Mack alluded to earlier is that, you know, with functions, typically one thing is vendor lock-in. So typically with a cloud vendor, you're using their functions, their managed functions offering, and you're kind of limited to that function only running on that particular cloud provider. But with the open source runtime, that opens up some of the possibilities of where you can run your functions. And what enables that is taking your function and thus putting it into a container. And then you can run that container wherever you want. You can run it in Azure. You can run it on-prem. You can run it on your on-prem Kubernetes cluster, or you can run it in another cloud provider that's not Azure as well. So that's one of the benefits of that portable runtime, where you can take that runtime, put in a container with your function, and then run it anywhere. A quick demo where we will set up a function and then put it in a container. So what we'll do here is we'll set up our local function to run local, similar to what Mack did. Build that container to Docker Hub. So kind of simple function built out. We're going to use JavaScript, and then we're going to build out that Docker file. So it went ahead and built out the scaffolding for the function, including with the Docker file that we need. So we'll just hop in that directory. And now that we're in that directory, let's do another HTTP trigger for simplicity. So we'll create a function. We'll name it just HTTP example, and then utilize the. So we'll go ahead and run that. Okay, and trigger for our function, and then to go ahead and start that, we'll run func start. Core tools runs again. So again, running that runtime locally, and now our function, and we've executed that function. So running locally. The next step is to go ahead and build that Docker image. So go ahead and get a new line, and then one of the first things we need to build. So we'll go ahead and run Docker build to build out that container. So it went ahead and built out that container. And then what we'll do next is go ahead and run that container image. And as it's building out the container image, what we do is, if I go to my local host, I'll move this over, is now our function is running. So now our function that we added to our container is now running locally. So from here, now we want to take that function that's running the container and then push it to Docker Hub. So what we'll do is and then we'll go ahead and also make sure I logged into Docker, but let me make sure I still am logged in. Maybe I wasn't since it's taking so long. Okay, now we're logged in. And then what we're going to do is push, and I need to add and Docker push, and this should push it to Docker Hub. And then boom, we're done. Now that we have it on Docker Hub, the next step would be to get it added to our function, so or into Azure. So what we'll do here is built out a resource group earlier, and what we want to do is to what I do is add a function. Oops. So So we'll need to build out a function. And then we'll come in here. It's like Docker container. We'll name, whatever our name for our function app. And then we'll go ahead and deploy this function app. And what you can do is then take, you'll be able to take your image name that you used to on Docker, pull that Docker image into your actual function, and then you're able to run your function that's resting inside the container and run it on Azure. Again, you can run on premise. There's some flexibility there with the functionality of putting functions into containers. So it breaks down some of those barriers of being stuck to one particular vendor, and you get the flexibility of containers as well. I think for the last few minutes, we can take some questions.